We're now going to try an application question using the quadratic formula. Our question here says a frog hops off a log along the arc h at d, and h at d is just notation. It really just means height. It's something called function notation. We've talked about that before. So h at d equals negative 0.2 d squared plus 1.7 d plus 5, where h is the height of the frog's jump in inches, and d is the horizontal distance from the log in inches. So the very first question says, how far did the frog jump? And I find questions are easier to do if I can see what it is that we're talking about. So we have a log, we have a frog, and he's going to jump off the log and likely land somewhere on the ground. And what we want to know is how far away from the log is he going to land when he jumps off that log. So when I think about this in terms of a graph, the ground would be our x-axis, and then our y-axis should be the height of the frog, and it should start from where he begins his jump, right? That's where the y-axis is going to go. So the question says, how far did the frog jump? What it's really asking us to find is our x-intercept. So what I want to do is find a way to find my x-intercepts. And we know how to do this by factoring. And we can factor, but I do see that there are decimals in there, and I'm not a big fan of factoring when we have decimals. So our other option is to use the quadratic formula. So I'm going to start by listing my a, b, and c, and then I'm going to substitute those numbers into the formula and calculate how far away the frog landed. So a is going to be the number in front of our x squared, and in this case it's a d squared, so it's negative 0.2. Our b is the number in front of the x, or in this case the d, which is 1.7, and the c is our constant at the end, which is 5. Okay. The quadratic formula we went over on the last part, we have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And then all I'm going to do is substitute in for a, b, and c. So b is 1.7, so negative b is going to be negative 1.7 plus or minus the square root of b squared, so 1.7 squared, minus 4 times a, which is negative 0.2, times c, which is 5. And that's all divided by 2a, so 2 times negative 0.2. At this point, I am going to use my calculator to calculate what's underneath the square root. So really important, if you do have a negative number in here, to put brackets in. If it's a positive number, it's not such a big deal. And everyone's calculator is a little bit different. But I'm going to do 1.7 squared. And if I want, I can actually do bracket 1.7 bracket squared minus 4 times, and then negative 0.2 times 5. And I end up with 6.89. And then 2 times negative 0.2 is negative 0.4. Now, when we were talking about the quadratic formula before, we talked about using exact answers. However, when it is a word problem, a real life problem, we don't usually use the exact answers. We tend to use the decimal. It makes a little bit more sense when we're talking about how far the frog jumped. So I'm going to split this into the two answers that I should get. One when I do plus, and one when I do minus. So you can actually write out negative 1.7 plus the square root of 6.89 over negative 0.4, and then do the minus, or you could just have calculated and then written the answer down. So I'm going to use my calculator to calculate the first one. So I'm going to do negative 1.7 plus the square root of 6.89. And then it's really important to hit equals before you do your dividing, otherwise you will not get the correct answer. So divided by negative 0.4. And I get negative 2.312. So I'm going to leave 2 decimal places, so that's going to be negative 2.31. And since I did round, I am going to put that little dot to show that it's approximate. And then we're going to try it, but this time with the subtraction. So negative 1.7 minus 6.89, the square root of 6.89. Make sure you hit that equals before you divide. Divided by negative 0.4, and I get 10.812, so that's going to round to 10.81. And I put the little approximate sign on there to show that we did round that answer. So I ended up with a negative answer and a positive answer. And the positive answer to me makes sense, that here we should be 10.81 inches away. The negative answer is what happens before the frog jumps. So the parabola that it's modeling the jump, right, would have had a part of the parabola before he made his jump, even though we don't worry about that. So this would have been where the negative 2.31 is. But really, his jump starts at 0 and ends at 10.81. So he has jumped 10.81 inches. So the frog jumped 10.81 inches. Now there is a second part to this question. It says, how high above the ground did the frog jump? So when it's asking how high above the ground did he jump, it is asking us to figure out that point right there at the highest point, and that is called the vertex. And to find the vertex, we learned back when we were sketching my intercepts that you can find the vertex by taking your 2x intercepts and finding the halfway point in between them. So we're going to do that. We're going to take our 2x intercepts of negative 2.31 and 10.81, and we are going to see if we can find that midpoint in between them by adding them together and dividing by 2. So I'm going to add negative 2.31 and 10.81. I'm going to add them together and divide by 2. And I get 8.5 over 2, which works out to be 4.25. So what that tells me is that the frog is going to hit his maximum height when he is 4.25 inches away from where he started, but it still doesn't tell me how high he's gone. This just tells me how far away he's going to be from the log when he hits that height. So if I want to know how high he is, I'm actually going to take the 4.25 and I'm going to substitute it into our equation for height everywhere I see a d. So we're going to do negative 0.2 times 4.25 squared plus 1.7 times 4.25 plus 5. Let's give that a try. So to figure out my height, I'm going to do negative 0.2 times 4.25 squared plus 1.7 times 4.25 plus 5. And then I'm going to calculate on the calculator. So negative 0.2 times 4.25 squared plus 1.7 times 4.25 plus 5. The calculator's giving me a little trouble. 1 second. And I end up with 8.6125 inches. So you could round that and say that it's approximately 8.61, or you can state the whole thing since we do have the full number. So I'm going to say the frog jumps, or he jumped 8.61 inches high. Now, the next question down says, how tall was the log? And if I take a look at the picture that we drew, the log is here at our y-intercept. So wherever the frog started on the y-axis, the y-intercept is how tall our log is. So to find the y-intercept, we always sub in x equals 0, or in this case, d equals 0. So I'm going to take my equation, and everywhere we see a d, we're going to put in 0. So my height is negative 0.2 times 0 squared plus 1.7 times 0 plus 5. Now 0 squared is 0 times negative 0.2 is 0. 0 times 1.7 is 0. So really all I'm left with is 5. So the log is 5 inches tall. All right, the next question says, state one reason why the frog might have jumped off of the log. Lots of possibilities. Maybe he saw a tasty fly. Maybe he got scared. Maybe he was hot and wanted to go for a swim. I'm going to say he saw a tasty fly. All right, and the last part is the domain and range. So we want to find the domain and range of what we call the relevant part of the function. So we're looking at the thing that actually models the frog's jump. So if I go back up, okay, it is the ground. So the frog starts on the log, and he goes up, and then he comes back down, and he's not going to burrow down into the ground. If he was jumping into water, maybe, but he's not. So he's going to stop when he hits the ground. And we also really aren't interested in the part of the curve that came before he starts his jump. So for the domain looks at the x values, or in this case, the d values that make sense. So we're looking at his jump starting at 0 and ending at 10.8. So for the domain, it's going to be all the numbers between 0 and 10.81. And for his height, we're looking at his lowest height, which is actually when he hits the ground at 0, to his highest height, which was here at 8.6125. So his heights are everything between 0 and 8.6125. So for the domain, we usually start with XER. In this case, it's D for distance, so DER. And then I'm going to say the distances were everything between 0 when he started and 10.81 when he finished. And the D is all the numbers in between. And then we use our greater than and less than signs, and the arrows should point towards the smaller number, and since 0 is smaller than 10.81, they're going to point that way. And I'll finish off with a nice little curly bracket there. And then for my range, this time it's height, so we're going to say HER. And the height was between the ground at the lowest and our highest point, which was 8.61 or 8.6125. It's up to you. You can write either. And then H is all the numbers in between. We point towards the smallest number, which is the 0. And that's our domain and range.